So this is the third problem in my Math 420 Advanced Calculus Exam 1 Superset. It says prove or give a counterexample. Suppose that there exist two sequences, a sub n and b sub n, such that the limit of a sub n is equal to L1 and the limit of b sub n is equal to L2. Then the limit of a sub n times b sub n is equal to L1 times L2. So the proof, first we're going to suppose that the limit of a sub n equals L1 and the limit of b sub n equals L2. Well, we want to show that for all epsilon that are greater than 0, there exists an n that's an element of the natural numbers such that for all n greater than or equal to capital N, a sub n times b sub n minus L1 times L2 is less than epsilon. So let's do a little bit of algebra to manipulate this absolute value. So we have a sub n, b sub n minus L1, L2. And that's the same as if we did a sub n, b sub n minus b sub n times L1 plus b sub n times L1 minus L1, L2. So these are equivalent statements because these two add up to 0, so we didn't really change the equation. So that's equal to a sub n minus L1 times b sub n plus L1 times b sub n minus L2. So then by the triangle inequality, that's less than or equal to the absolute value of b sub n times a sub n minus L1 plus the absolute value of L1 times the absolute value of b sub n minus L2. And that's by the triangle inequality. So since b sub n converges to L2, b sub n must be bounded. So for some m that's an element of the positive real numbers, the absolute value of b sub n is less than m. So b sub n times absolute value of a sub n minus L1 plus L1 times b sub n minus L2 is less than m times a sub n minus L1 plus L1 times b sub n minus L2. And that's by substitution. Since the limit of a to the n is equal to L1, for epsilon 1 equal to epsilon over 2m, which is greater than 0, there exists an n sub 1, which is an element of the natural numbers, such that for all n that are greater than n sub 1, a to the n, or a sub n minus L1 is less than epsilon. Similarly, since the limit of b sub n equals L2, for epsilon 2 equal to epsilon over the absolute value of L1 times 2, which is greater than 0, there exists an n2, which is an element of the natural numbers, such that for all little n greater than or equal to n2, b sub n minus L2 is less than epsilon 2. Whoops, this should be epsilon 1. So we have a sub n minus L1 is less than epsilon 1, and b sub n minus L2 is less than epsilon 2. Let's let n equal the sup of n1, n2. Then for all little n that are greater than or equal to capital N, we've got m times the absolute value of a sub n minus L1, and I'm just rewriting what was above, plus absolute value of L1 times b sub n minus L2. And that is less than m times epsilon 1 plus absolute value of L1 times epsilon 2. So this was by substitution. So then that equals m times, if we look at our epsilon 1 up here, epsilon divided by 2m plus absolute value of L1 times epsilon over 2 times absolute value of L1. So these guys cancel and these guys cancel. We end up with epsilon over 2 plus epsilon over 2, which equals epsilon. So that means that a sub n times b sub n minus L1 times L2 is less than epsilon for all little n less than, or greater than or equal to capital N. Therefore, the limit of a sub n times b sub n is equal to L1 times L2.